So example 1, it reads, Xavier, quit talking. It says, Alex opens a checking account and deposits $125 every week. Alex adds $25 to the account. He decides to also open a savings account, and he deposits $225 into that account. Hold on. And after opening the account, Alex adds $35 into it each week. So we have a weekly rate. Wyatt, good question. A checking account, a checking account and a savings account. Money in a checkings account, you spend, so that's linked to like a debit card, where you just swipe, and it takes away from that account. A savings account doesn't have a card that's linked to it, so you just save money. One is for spending, one is for saving. No. So so you know what like a check is, right? Yeah. So before credit cards and debit cards, a checking account was for when you wrote checks and you cashed them and you would spend money. So it's still called a checking account. You can still write checks, but people just use debit cards. So Alex has both a checking and a savings account. You could use like a debit card. It's the same thing. So we have two different accounts. So that means we're going to have two different expressions. So for the checking account, how much does he deposit? $125.
Yep.
And I meant to type in per week. So how much, it actually does say that. Every week, he adds how much to the account? 25. So how do I represent that as an expression?
125 plus 25W.
Plus 25W. We have this rate right here. So we're going to represent that with a letter, a variable, and a coefficient of 25. Yeah. We're adding because even though it's a checking account and it's meant for spending, you are still having to add money to it so it doesn't run out. Alex, hold on, dude. I got you. Now, he's going to deposit money into his savings account. And his savings account is for money that he does not plan on spending. So I need an expression for his savings account. Josiah, give me an expression for his savings account.
Okay, so 225, Yeah,
you're right.
225 plus 35W.
That is correct. You had a question too?
Can I go turn this into the office?
Not yet. So, we now have to simplify an expression. And then example 1, letter A, is it asking for one account or both accounts?
For both.
Both. So, if it's asking for both accounts, how do we represent a combined amount?
You combine
combine like terms, right? So we're gonna
25 and 35.
we're gonna go ahead and write the expression out the long way. Whoops. 225 plus 35W. And then Xavier, you're exactly right. Combine like terms. So Sophia, do me a favor. Can you rearrange the equations so that our like terms are together?
25W plus 35W, and then plus sign, and then 125 plus 225.
Yep. And then Xavier, finish it out for me. Combine like terms.
Wait, where I can't even see. Oh, like add them? Okay.
Yeah.
60W, and then, it's like 350.
Yes, sir. We're not done yet. What can we do?
Simplify or
Factor by how much?
60.
Not 60.
No, 30.
Not 6.
Five.
They both end in zeros. They both end in zeros. So we can factor by 10. Yes. So if I factor by 10, this is the easiest one. The zeros just cancel out. So I have 10 on the outside. And then I have 6W plus 35. So smart. Can you factor twice? If you find yourself factoring twice, it's because you did not use the GCF, the greatest common factor. So let's say you have like 10 and 40. If you factor by 2... what did you... I see. Yeah. You want to combine like terms first and then factor, yeah.
I didn't do that. I still did the same thing.
If you factor twice, it still works. Just, want me to show you later? I'll show you later. Okay.
never got to that.
So I know. Example 1, we're still on example 1. Letter A, we have the expression 10 times the quantity of 35, or it's really 6W plus 35. And then letter B says, how much will Alex have after 5 weeks? Well, how do we figure that out? Let's go with Alex. How do I figure it out?
60 times 5.
Not quite.
Wait, what?
How do we find out? So what does W represent in our expression?
Weeks.
Weeks. And then letter B, we're asking for how many weeks?
5.
So we have to plug in the number 5 for.
W?
Yep, so we're going to plug in,
It's just 30.
not quite.
What?
We're going to plug it into our expression. Whoops. I have to, yeah, it's a bracket at the end. All right, so Alex, it's not just 30. We have to actually solve for the entire expression. So just break down. We have to use order of operations.
6 times 5 is 30. Plus 35 is 65. 65 times 10 is 650.
Yep, and then what is my label? Yes, it is dollars. So we have to realize that it's a combined amount in both accounts. So he has $650 total.
Flip it.
That's about it. Yeah.
I didn't even I got $650.
You're still gonna get it because they're equivalent expressions.
25 times 5 plus. Wait, Ross, right? 30 plus 35. And then I did 225 plus 35 times 5.
It'll get you the same number because technically they're equivalent expressions, which means they're equal. They just look different.
And, well, but then I thought you said you wanted this like accurate. On that time. So I did.
For letter A, yeah.
And then so then I did 250 plus 400. This is how you got when you add.
Well, you did.
Yo, Ross,
He said he got 250 plus 4.
I got 250 plus 400 and factored by 10, and I factored again by 5, and I got 50. That's parentheses 5 plus 8.
That works.
Did I give you that skating money or just one?
That'll be Miss Ward. Brother. Okay, can I clear it?
Ross,
Are you raising your hand?
yeah.
What's up?
If you don't simplify, like on the quiz, if you don't simplify the expression from 60W plus 350 to 10 to the quantity of 6W plus 35, are you gonna mark it off?
It depends what the question asks. If it says to simplify and a factor, then yeah.
Oh.
Or if it says to simplify, yes. If it says if you have to simplify, it'll tell you. All right. So example 2, it says write an expression for the following surveys, and you're gonna have something like this on your quiz. Letter A says we want 30 more than 2/5 of. Yeah, 30 more than 2/5 of customers prefer bananas. So we have to write an expression. What letter do we want to use for customers? C. So Wesley, letter A, you got it?
What? Make it.
2/5 C plus 30. It says 2/5 of customers. What does the word of mean? No, not division. Multiplication. Multiplication. Of equals multiplication, to multiply. So when you see that word of, you're multiplying the number times the variable. And then whenever it's 30 more or 30 less, you're adding and subtracting. Letter B, 10 fewer than 1/5 of customers prefer apples. So let's go with Avedis. We no longer have 2/5 of customers. We have 1/5 of customers. So 1/5 C. And are we adding or subtracting 10? Why are we subtracting? Because it's fewer, yeah. All right, Giselle, you're going to do C. So we have 5 more than 1/5 of customers prefer oranges.
Okay, so it'd be
Let's look for keywords. What word in that phrase represents multiplication? Which one? Of, yeah. So of is associated with what to numbers or values? Not 5. So what are we multiplying? Or what two values are we multiplying? 1/5 5 times 1/5 of what? Not oranges. What does the problem say? Customers. And how do we represent customers in this problem? The letter C. And then is it 5 more or 5 less than this? So is that adding or subtracting? Yes. That is correct. You're going to see this on your quiz. Key takeaways. If you see the word of, you're multiplying. If you see more or less, you're either adding or subtracting.
Yes, sir.
If it tells you to simplify, you got to simplify. If you're going to factor, you have to use the GCF. You guys ready?
Yes.
All right.
One more question.
Yeah.